This is a great introductory question on prime numbers. And before we do it, let's take a little review on what's called prime factorization. So I'm going to go to a new slide here. Suppose we had the number 210. And I asked, what prime numbers can you multiply together to get to 210? Well, the formal way to do it, so to speak, we'll start with the lowest prime, so that's 2, the smallest prime, and ask, all right, well, 2 times what is 210? Well, it's 105. Okay. Can we continue with 2? Does 2 go into 105? Well, no, because it's an odd number. So how about 3? Does 3 go into 105? Well, the divisibility rule by 3 is that if you add the digits, so 1 plus 0 plus 5, that's 6. If the sum of the digits is divisible by 3, then the whole number is divisible by 3. So 105 is indeed divisible by 3. So let's do it. Let's take 105 and divide by 3. See how many times 3 goes into 105. Well, 3 goes into 10 3 times. 3 times 3 is 9, so I'll subtract 9 with a 0 added to it. 105, 15. 3 goes into 15 5 times. All right, so 105 is 3 times 35. So I'll write here in my factor tree 3 times 35. All right, 35, is that divisible by 3? Well, no, 3 plus 5 adds to 8. That is not divisible by 3. So how about the next prime? 5. And is 35 divisible by 5? Well, sure it is. 5 times 7. So I'll write on the left here, 210 equals 2 times 3 times 5 times 7. You can see why the tree is written in the way it is. It's kind of a nice order. So I'll underline 2, then 3, then 5, and then we end in 7. The prime factorization of 210, 2 times 3 times 5 times 7. Now, in the upper left here, I'm going to write 420. What's the prime factorization of 420? Well, it's 2 times 210. So it's similar to the prime factorization of 210, but 420, I'll write it down here. 420, it's 2. Well, 2 appears twice, so 2 times 2, so 2 squared. 2 squared times 3 times 5 times 7 would be the prime factorization of 420. So that's sort of the formal way to do it, so to speak. Let's go back to our question. 7,150. How do I want to do the prime factorization of that? Well, as a practical matter, is the quickest way to do it to start by dividing by 2, the smallest prime? Well, no. The fastest way to do it would be, let's say, multiply 10 by 715. Then, of course, 10 is 2 times 5. So we've got the prime factors there. How about 715? Well, let's see. Of course, not divisible by 2. How about by 3? Well, I'm going to write 715 up here on the right. And the divisibility rule by 3. If the digits of the number, in this case 7 plus 1 plus 5 adds to 13, if that number is divisible by 3, we just talked about the divisibility rule, then 715 would be divisible by 3. But 13 is not divisible by 3, so okay, so we got to move up. Not 3, but how about 5? Is 715 divisible by 5? Well, of course it is. If a number ends in a 5 or a 0, it's automatically divisible by 5. So I'm going to write 715 divided by 5. So what's that? 5 goes into 7 once. So I'm going to subtract 5 with 2 zeros. We get 215. 5 goes into 21. Well, it goes into 24 times. So I'll write a 4 up here. 5 times 4, 20 with a 0. So 15. 5 into 15, 3 times. So 5 times 143. So now you wonder, is 143 divisible by a prime? Well, let's see. We talked about 2, 3, 5. What's the next prime? 7. Does 7 go into 143? Well, it goes into 14 twice, but it's not going to go into 143. Okay, so 7's not going to do it. I'll erase that. How about the next prime? Well, that would be 11. Does 11 go into 143? I'll write this on the left. 143 divided by 11. 11 actually does go into 143. Goes into 14 once, so I'll subtract 110. We're down to 33. 11 goes into 33 3 times. So 11 times 13. 11 times 13. So the prime factorization, I'll write it below, 7,150 equals, it's what? So I'll look underneath. We have 2, we have 5, we have 5. So 2 times 5 squared times 11 times 13. So times 11 times 13. That is the prime factorization of 7,150. A little low on space there. How many primes is that? 1, 2, 3, 4. So the answer is 4.